Hey guys, it's Obi here. Last week we talked about some of the air conditioning system components. If you remember, we were talking about a CCOT system, which stands for Cycling Clutch Orifice Tube. So we covered the compressor, which should look like this, and the orifice tube, which should look something like this. And if we remember, the orifice tube and the compressor are the split between the high and the low side of the system, right? So we have to have two of those to separate the system into high and low pressure zones. So this week we're going to talk about the condenser and the evaporator, okay, and the accumulator. So the condenser is going to be located outside of the vehicle. So this is, in all instances that I can tell you, is going to be located in front of the radiator on the vehicle. Okay, so it's using the cooling fan from the engine, and it's going to be cooling the coolant down from there. So the reason it is called a condenser is because it is condensing the gas from a high pressure gas to a high pressure liquid. Okay, so if we remember that latent heat of evaporation and condensation, as we take the heat out of this is going to make that gas cool down and condense back into a liquid, which is kind of what we want, okay? So there's kind of two different systems you're going to see with a condenser. So what'll actually happen, we'll look at the one here on the left first. So this is what's going to be called a serpentine flow. So if we see, we have a radiator, we have the cooling fins in here just like we would see in a radiator, but we have a tube that is circulating and serpentining back and forth until it gets to the outlet. So there is one path from the inlet to the outlet, okay? So what actually happens is as the freon comes in under high pressure from the compressor, it is going to begin to give off some of that heat. And there, you remember, there is a direct relationship between temperature and heat. So as we pressure and heat. So as we remove some of the pressure, some of the heat, the pressure is going to begin to drop a little bit, and that is going to allow our freon to condense. Okay, so we'll start to see gas up here, and then somewhere in the middle, we will usually start to see this collecting into liquid, and we should be fully liquid by the time we leave the condenser. Okay? So there is another style you will see. So basically it's a dead giveaway that you have a serpentine system if you have these curved tubes on the edge. If you see one that looks like this little round tube that goes all the way up and down, this is what's called a parallel flow system. So this actually is much closer to the radiator in your vehicle, where it has a tank on both sides, except this is actually split into a couple different sections. So basically the fluid or the freon is going to come in, the gas, and it's going to follow these first three cores. Then it's going to drop through that tube and continue on to the next three cores. So even though it has whatever core it would like to take, it has a couple different choices, it still has to go back and forth, okay? So this is kind of like a modified system where it's parallel but still serpentine. Whereas a radiator for the cooling system would just be a tank on this side, and it could take whatever tube it wanted to get to the other side. Okay? But the whole point of a condenser is to condense the freon gas down to a liquid and to remove heat from the freon. So that is one half of our system, okay? So the other one is the evaporator, which it's going to operate exactly the same way. The difference is we are doing the latent heat of evaporation here, and what we're going to do is we're going to absorb heat into that so we can condition the cool air going through the evaporator. So when this goes through, what happens is the exact opposite. So we will boil the freon. We will make a really low pressure, which will make the freon boil into a gas, and as it boils, we can pull a lot of heat out of the air, okay? So there's two things that happen at the evaporator. One, it is going to super cool the air or get the air really, really cool. The other thing that's going to happen is actually we're going to have condensation form on the evaporator because air can only hold so much moisture, and as the temperature of the air drops, the ability of the air to hold moisture is going to drop. That's why the air is really dry in the wintertime and is super humid in the summertime. Warm air can hold a lot of moisture and cold air cannot. So once we get cold enough, we exceed the capacity of that cooled air to contain that moisture. So we'll start to see water dripping out. That's why we always have to have a drain on the AC system. Okay? An AC drain. That's why when you kick your AC on, you will see water draining underneath. So how do we make the Freon boil in the evaporator? Well, that is still from the orifice tube. So the orifice tube is going to be located pretty close to the evaporator. It's probably the last thing it's going to get to. Before it gets there, there might just be a short tube, and that is it. So the orifice tube is going to make a restriction, which is going to create a low pressure area, and the low pressure area on the opposite side is going to induce boiling in the Freon. Okay? So when we think boiling of water, and water boils at 212 degrees. Well, Freon doesn't do that. That's why we use Freon, because the pressures match what we're trying to achieve. So Freon under no pressure will actually boil at like negative 20, I think is something like that. So under pressure, we can change the point at which it will begin to boil, just like we do with the cooling system. Okay, so this is a good little picture of the system that we would see. So this is our high pressure line coming in, and this fitting right here, you can kind of see that is actually where our expansion valve, or I'm sorry, our orifice tube is going to go. So that'll go into our evaporator housing, go all the way through the evaporator, and it comes back out. And that brings us to our last component that we're going to talk about today, and that is the accumulator. Okay, so the accumulator looks like this, and its purpose is to ensure that only low pressure gas is going to reach the compressor, because remember, we cannot compress a liquid. If you try to compress a liquid, bad stuff will happen. Don't do it. It's a bad idea. So it will also act like a reservoir for excess Freon. So think of it like the overflow tank for a cooling system. It kind of operates like that. Obviously it's under pressure, but there is a range when you fill these, when you charge them with Freon. So this is going to take up some of that excess Freon, okay? So this is what the inside of an accumulator actually is going to look like. So there's a couple things in the accumulator. If we see, we have two fittings here. One of them is an inlet from the evaporator, and one is an outlet to the compressor. So the way this system is going to work, if we notice, we have air or Freon coming in, and that is just dumping right into this tube. And you can see the outlet actually makes this big curve and comes all the way back up. Okay? So what actually happens is that the Freon itself has to boil before, so it has to be a gas, because our liquid Freon is probably going to be floating around in here somewhere. So it has to become a gas until it can get high enough to actually go through this tube. And then it's able to be pushed out or sucked out to the compressor. Okay? So basically, because we have that tube up here, we ensure we're only getting gas to the compressor and no liquid. There is one other thing that an accumulator does do. We have this guy right here, which is kind of hard to tell if you see this little line. This is actually a desiccant bag. So one thing that air conditioning systems hate, absolutely hate, is moisture inside of the AC system. If that happens, the moisture can actually freeze in the orifice tube, and that blocks the system, which creates excessively high side pressures and excessively low side pressures. So basically you're trying to pump, but you have no flow. So that is very damaging to the compressor. Obviously the air conditioning system won't work, and it can be exemplified in quite a few different problems. So let's go back and let's just review everything on the orifice tube air conditioning system, the cyclone clutch orifice tube. So it all starts with the compressor. We're sucking in low pressure gas, compressing it to high pressure gas. Okay? It is going to go through the condenser. We're going to take that heat out of the Freon through latent heat of condensation, and this is going to condense from a gas to a liquid. Then we're going to be on the high pressure or liquid side of the system. So we're on the high pressure liquid, and we hit the orifice tube, which creates a low pressure area here and then forces or induces boiling in the freon. So as that freon boils, it makes a super cold area. So that air traveling across the evaporator will now want to boil, or will now want to give all that heat up, and it will cause condensation, and the moisture will be dripping off this evaporator. Now, in an ideal world, we will have nothing but gas reach the accumulator, but all things being equal, it's never completely perfect. So we might still have some unboiled freon over here. So the accumulator acts like a reservoir for that and ensures that only low pressure gas is going to reach the compressor. So we make sure the system is going to work properly, okay? Alright guys, I hope that gives you an overview of how a cycling clutch orifice tube system is going to work. I will talk to you guys tomorrow. Toby out.